So the title of this says light and how light and light interacts with matter. And so what I'm hoping, honestly, is that you can take that light now and think of it in terms of broader than just visible light, all types of electromagnetic radiation. So all of those cousins. What that energy is going to do when it interacts or hits the matter, it has some choices. One is that energy or light can be absorbed by that matter. One is that energy actually, or that light that can actually be just simply passed through the matter or transmitted. And the other is that there is an interaction between the matter, and basically that energy can either be reflected in a known angle, basically, or just kind of randomly scattered. Okay, so those are kind of some options with regard to energy interacting with matter. Okay, so can you kind of see over here we have people watching a movie. And so photons of light are being sent to a white screen, and you can see, or if you think of a screen, or most objects actually, they are scattering light that lands on them. So notice that we have two observers here, and this is kind of neat if you think about it. Both of these observers are privy to seeing all of the photons. So here's your projection booth. Okay, it's sending light down there, okay, that has a certain movie it wants to project. And notice that for every, and I'll kind of pick on his nose, for every location that it lands on, it is actually going, okay, scattering in a multiple of directions. So that's why she sees his nose and he sees his nose. Okay, so light is scattered. It's a wonderful thing. So reflection is a little bit different. So I said you can anticipate the angle of reflection, basically dependent upon a line drawn normal to the reflecting surface. But kind of the deal here is, how do I say this? If we have a person standing here, okay, and we had an eye, okay, over here, this is my eyeball, not a very good eyeball, okay, but this eye would see that person, okay, over here, not so much, okay, so it's just, in the mirror anyway, it might see him directly. So it's a limited sort of scattering. So I think I mentioned this before, kind of the acronym Roy G. Biv. Okay, it's just a kind of a silly way of remembering the colors of the rainbow. And so red, though, keep in mind that red is the longest wavelength, okay, longest lambda, and violet is the shortest. So here's one thing that, and I have a figure to kind of emphasize it, but I am just amazed that whenever if we see, for instance, if we see something blue, okay, so an object, this is my object and it is blue, and I kind of have some examples coming up here. Basically, if you turn on, we'll just say you're out in the sunshine, okay, all colors are landing on that blue object. It's like my grass is blue, but no, an object is blue. So basically we have Roy G. Biv, okay, you know, white light is a mixture of all those colors, and all colors except for blue are absorbed, okay? Yeah, it's like, is that right? So basically blue is kicked back, okay? And so that means Roy G. Iv are absorbed. Okay, there you go. This actually is why, or similar to then, if you're wearing something white, okay, let's check this out. If you're wearing something white from the sun, if you get Roy G. Biv coming from the sun, okay, guess what? You have Roy G. Biv going back, and so nothing is absorbed. Black, just the opposite, everything's absorbed. Okay. I have to focus on this, right? So we have some examples. Nice snowy winter will be here before we know it. And so white light coming from the sun. And if you've ever gotten burned when you went skiing or something like that, or played out in the snow when you shoveled your snow. Isn't that like adding insult to injury? You shovel your snow when you get snowburned or you get sunburned. So what's happening is those white reflective surfaces are sending, everything right back to you. The green tree, you see that green is scattered. Roy Biv is absorbed. Isn't that cute, right? Okay. Like I said, the white snow, you have all components of the, of white light, going onto the snow and nothing absorbed. It all scattered back and combines again. So just kind of some examples in here of a guy, green hat again, green hat alert, of a guy looking at a red chair. Notice we have a couple sources of light from a lamp, and light from the window. Okay, but bottom line is that we see it as red. He sees it as red because that is the color that's reflected. So what's absorbed? Oi G Biv. So